The Alliance Hypothalamus Artificial Intelligence, IBM and TD SYNNEX presents its services to oil and gas enterprise-wide optimization. Oil and gas enterprise-wide optimization. Industrial enterprise-wide optimization. Industrial value chains can be conceived as multiple links that work as the union of two chains, supply and demand. The supply chain is associated with production activities, while the demand is associated with the business. These chains cannot be thought of as mutually exclusive, as the border that could divide is fuzzy. What is clear is that they are complementary and that their union affect all the value chain. HI models mainly support two types of industrial planning activities. SAND-OP, sales and operations planning activities that are carried out periodically, usually every month or every week, to coordinate the selling products with production activities. IBP, integrated business planning, activities that are carried out periodically, usually every 6 months or every year, and aim to perform integrated value chain of the organization planning. The solutions offered by HI to the general industrial sector are based on the integration of following groups of solutions. HI DCO, Demand Chain Optimization. HI SCO, Industrial Supply Chain Optimization. HI Bio-Industrial Supply Chain Optimization, and HI HRA, Human Resources Analytics. In 2006, Jeremy Shapiro published the article Beyond Supply Chain Optimization to Enterprise Optimization, in which he stated, "The recognition that strategic supply chain planning should be integrated into larger business planning exercises will serve to break down barriers to fact-based decision-making. Starting from SCM or supply chain management, focused on production, as a first step in standardized planning." Shapiro envisions what the S&OP, sales and operations planning model, formally is, as the integration of sales and production planning. And finally, it establishes what is now IBP, integrated business planning model, which involves the financial planning as part of planning. The actual experience has not been as Shapiro envisioned it, but every time we are close to it, with the incorporation of ALM models, assets and liabilities management, as part of supply chain planning. In the paper, Enterprise Profit Optimization, EPO, The Next Wave in Value Creation, Robert Phillips from Manugistics, said, integrating pricing actions and supply chain actions, EPO provides companies with the tools required to quickly and effectively achieve real optimization goals. Until the advent of Industry 4.0, S&OP modeling was concentrated on production modeling. Considering as parameters exogenous, the result of models for sales and maintenance. The financial results are obtained from a post-processing, in some cases in Excel books. In the ERA of Industry 4.0, S&OP may be constructed based on 8 groups of solutions or systems: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. HI view the systems as groups of equations that must be included in the S&OP mathematical problem depends on many factors, so that there is no revealed truth regarding what the S&OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler wants to consider in the model. This evolution gives rise to enterprise-wide optimization. Enterprise-wide optimization, the comprehensive and complete view of the value chain, improves competitive advantage, reduces costs and increases profits. Therefore, managers seek to comprehensively optimize the planning and scheduling activities of their value chain, which was originally understood as the coordinated sum of supply chain management, SCM, and demand chain management. Today, AWO has expanded and covers all functional areas of the organization, including financial and human resources chains. There are 4 dimensions to the optimal synchronization of a supply chain, namely, Functional associated with the purchase, manufacture, transport and storage of industrial inputs and products. Spatial associated with activities through industrial facilities and different forms of markets. Hierarchical, associated with the impact of decisions, strategic, tactical and operational, and business. Enterprise integration makes SCM one of the components of a broader view of integrated planning. They respond to the purposes of strategic and tactical planning within the organization. Hierarchical coordination of planning tools. It is traditional to organize decisions hierarchically into strategic, tactical and operational. The operational decisions are divided into the scheduling and advanced optimal control. However, due to the technological progress generated by Industry 4.0, mainly in relation to smart metering systems, nowadays we can talk about a new type of online optimization modeling, real-time distributed optimization. From the point of view of mathematical modeling, hierarchical levels are intertwined and coordinated through the boundary conditions in time, and common modeling that can be shared. The modeling strategy of HI is that all models of a decision support system can communicate with each other. Under the principle of transitivity of algebraic formulations, models grow in complexity as they descend from the hierarchy of decisions. All models share equations, mainly those related to the physical process. Therefore, they can be made in a continuous modeling process. The models of higher hierarchy will be more aggregated, in order to cover long periods of analysis, of the order of the years. The emphasis of the model should include the interpretation of the economic and technological future, so it is appropriate that they are stochastic optimized. As the models approach real time, the level of detail increases, and the planning period decreases, the most important being the engineering representation of the process. Spatial coordination is related to activities through industrial facilities in various regions and different forms of markets. The decision support systems, DSS, were conceptualized as a set of mathematical models that exchange information between them, working offline. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. High-oil AWO meets all the software solutions developed by HI, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum products supply chain. To ensure optimal decision-making at the level of strategy and tactics, the system must be considered, synchronizing the different links in the chain, in space, function, and time. The management of the complete oil supply chain must be based on the integrated optimization of the different links. It is one of the main research topics worldwide, due to the importance and impact of the products it handles. The support of this type of planning is complex, and therefore turns out to be a perfect field for the application of optimization tools, mathematical programming, in order to support decisions that allow the optimal coordination of the holistic supply chain. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of high-oil AWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. The current computational power allows to model detailed the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. Large-scale optimization and artificial brains. One of the fundamental ideas of the artificial brain is the atomization of the system, bottom-up approach, to integrate multiple mathematical models, using the framework of large-scale optimization methodologies, like multi-level Bender's theory, and Lagrangian relaxation. Given the complexity of the real world, which involves mathematical models of all types, linear, nonlinear, discrete, continuous, convex, non-convex, etc., it cannot be thought that with a single methodology, all the problems that make up an artificial brain can be solved. Therefore, it is required to have access to multiple large-scale optimization methodologies, which, Using the principles of cross-decomposition, connect all mathematical problems, to perform autonomous distributed optimization in real time. Oil and gas optimization solutions. Below are several optimization solutions, commonly applied in the oil industry. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. The table shows detailed solutions offered by IBM Log for oil and gas for upstream, exploration, and production. The table shows detailed solutions offered by IBM Log for oil and gas for midstream, refining, and chemicals. The table shows detailed solutions offered by IBM Log for oil and gas for downstream, marketing, and services. High Oil meets all the software solutions developed by High, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum product supply chain. The table presents a summary of the mathematical models developed by High for oil and gas transport optimization. All models that integrate an artificial hypothalamus must share a general data model in such a way that they are easily integrated. Galileo Galilei affirmed, "Mathematics is the language in which God has written the universe."